Dun. All right, good morning, everyone. Today is Friday, November the 12th. We are on day 3 of 4.06. So this first bell work problem, we actually did that on Wednesday at the end of class. So that one is, hopefully nobody did that one again. But if you did, that's cool. You should have got 2.727. What did everyone get for the second one? Approximately 0.5498. So the directions, it does say, does it say anything about rounding? No, actually, the rounding is all based on these. So you should have only used the givens. So there's actually only one correct answer, and the answer is this, 0.549. If you got anything else other than that, you are wrong. If you got 4 decimal places, you probably typed it in, which is also wrong. This is going to be a TGA question, and people who just type this in to your calculator to get an answer, you will get 0 points on that. That would be sad. So you must use these givens to do this. So let's take a look. What is going on here? So log base 4. So we need to expand. We need to expand this. Ooh, actually, this is a good one. So let's go through this. So expanding this, just let's do it real quick here. I'm not going to really spend a lot of time on explaining the expanding, but we all know that division becomes subtraction. So we have just rewriting our fraction here. We have 15 is just 5 times 3, and then over 7. So basically, in the end, we're going to have log base 4 of 5 plus log base 4 of 3 minus log base 4 of 7, right? Everyone got that one. That for your expansion, you probably spent at least 2 steps. I only did it in 1. All right, and then we would plug in everything that we know from the givens. So we're going to have 0 points. I'm sorry. We're going to have 1.161 for log base 4 of 5. So there's your 1.161 plus log base 4 of 3 is 0.792. And then here's the problem. Log base 4 of 7. That one isn't given to us, at least not really. Any ideas of how we can use the givens to actually figure out what log base 4 of 7 is? What do you think? Yeah, we're going to expand log base 4 of 49. Yeah, so we have to kind of manipulate that problem a little bit. So log base 4 of 49. How can I write 49 as a number, like a prime number with an exponent? Yeah, 7 squared. By the way, this is going to be just like one of your TGAs, so hopefully you're paying attention. Not that this is really that difficult, but if you haven't seen it, you probably wouldn't know how to approach it or how I want you to approach it on your TGA. And I hate for all of you who missed this problem just because you weren't paying attention to this. I know, Isaiah. I know you get it. All right, now what can we do? No, not square roots. Yeah, you can't. Yeah, it's not, you're not square rooting. Yeah, whenever you see that power to that 7, remember that is 7 squared. That's not the entire piece squared. So you can't square root it. Like you can't select just to square root that 7 squared. If that makes sense. It's kind of trapped. That it's kind of trapped with the log. Um, yeah, exactly. We're gonna move the 2 in front and then basically divide by 2. So that using our exponent properties, this exponent gets moved in the front. We get the 2 log base 4 of 7 equals 2.808. And then we would divide both sides by 2. And then we would get log base 4 of 7 equals now 2.808. Super easy to divide by 2 because everything is even. We get 1.404. Pretty easy, right? And that's the last piece we need to plug in to our equation we started on the left. So that's 1.404. All right, so now from here, once we have everything replaced with what it's equal to, we now we can type it into our calculator. And we type all that good stuff in and we get 0.549. It's not bad if you know how to approach it. All right, everyone feeling pretty good about this problem? Expect to see one just like it on your TGA. Okay. I think this TGA for Unit 4, I think is probably, I don't know. I think it's kind of easy, which is good, right? We're going to end on a nice, easy TGA. Okay, let's jump into day 3, change of base formula. Now, change of base, we're kind of going to get to at the end of this lesson. Well, not really at the end, more at the middle. But let's review some of this stuff. So inverse relationships, we already know this. Like if we had b to the x power, by doing log base b of this, these cancel out, x carries down. We know that already. Same thing for here. If we had log base b of x to free this x, we would just base b it, and then they would cancel out, x would carry down. So we know that from last week, a few days ago. Same thing for here. If you have e to the x, if you natural log it, natural log of e, this will carry down in front. Natural log e is 1. We know this already. And then when we have natural log of x, if we base e it, so e to the natural log of x, these cancel out, x would carry down. So this is just reviewing the inverse properties that we had on Wednesday. So we're going to use these properties to simplify these problems. So we're going to simplify. All right. I think these are a lot of fun. These are like puzzles. So you're trying to reduce it, simplify it, maybe get down to a single number. So we have 3 raised to the 4 times log base 3 of x. All right, let's use our properties. Who finds puzzles fun? I do, Brady. How dare you? Yeah, they're fun when we're almost done. Now, it's funny you bring up puzzles. My girlfriend got me a 1,000-piece puzzle of Dragon Ball Z, and I asked her last week if she wanted to help me put it together, and she said no way. Kind of hurt a little bit, but anyway, what should we do first? How should we start this? So let's go back. Let me go back to this page here. Remember, we're trying to use these properties. You know, like for example, this one right here, b raised to the log base b of x. If we can cancel this out, x will carry down. And I'm pointing to this one because this is actually the one that we're this inverse relationship that we're actually going to use for at least this first problem here. Yeah, that four needs to go somewhere. So where should we put that four? Yeah, so we're going to move this 4 to the exponent using that property. Um, got these on this page. So we're going to move that 4 to the exponent here. So now we have 3 raised to the log base 3 of x to the fourth. Now what can we do? Yeah, 3 log 3, that cancels out, right? And then the x to the, yeah, exactly. The x to the fourth carries down. So this cancels out. It's one of the inverse properties. And then the x to the fourth carries down. And then we're done. It's simplified. There's nothing else we can do. That is the answer. All right. Does everyone understand what we're doing now? Okay. Let's try another easy one. 5 raised to the 2 plus 3 log base 5 of x. What can we do? We can. Yeah, we can totally move this 3 to this exponent. What else can we do? So let me go on this page here because I didn't do it that way to start, but we can. So we have 5 raised to the 2 plus. Now you said you wanted to move that 3 to become an exponent to the x, and we can do that. All right, now what? I don't know. No, 2 doesn't disappear. I don't know. Why would the 2 disappear? Can't just go away. We need real math to support that decision. So let me show you a property that maybe you have forgotten. It's under this little blue thing here. You remember that property we learned in past math classes, and we even reviewed this. This is in your notes. It was either from Friday or earlier this week. The same base. For example, when you have a times m, sorry, a to the m times a to the n, this can combine to be a to the m plus n. Remember, same bases, you add the exponents. So for example, like 7 to the 3x times 7 to the negative 2. Well, look, same bases, so we add the exponents and combine it with the same base. So all we're doing here is we're going backwards. We're going to separate them to go from this form to this form. Yeah, so like Enzo says, we're going to have 5 squared. Well, look, Enzo. Look, it's adding in the exponents here, but when you separate it, it's multiplication of the factors. So same base, multiplication, you add the exponents, so we just go reverse. So multiply, yeah. So 5 squared times 5 to the log of that stuff. All right. And we could move that 3 to the exponent right now. It doesn't matter. like on the previous page, you want to do that first, and that's okay. But I'm doing it second. All right. So now we're on the same page, right? Did we all just forget this property? Because we don't really, we've used it in the past of going from this to this, but we've never actually used it going backwards because we didn't really have a use for it until now. Yep. So like you said, 5 squared becomes 25. And then the 5 raised to the log base 5 of x cubed becomes what? X to the third, yeah. And then we have our answer. Any questions on this one? Are your minds blown right now of like the fact that we can do this? I told you it's going to feel like you're doing like math for the first time because we're using properties that we haven't typically used in this way, and these different log properties. Bring a 5 in. I didn't. I did not bring just a 5 in. All right, so let's go back up here. So Brady, do you see this same base? This is a property. When you're multiplying and you have same bases, so like 7 and 7, right? 7 times 7 raised to this power times 7 raised to this power. When you have same bases, you can combine this into a single base by just adding the exponents. So 3x plus -2 is 3x minus 2. Okay. So going backwards, when you have two terms like this, 7 raised to the 3x minus 2, we can go backwards by doing 7 raised to the 3x times 7 raised to the -2. So the same thing for here. We have 5 raised to this sum, these two terms, and we can separate it by using this property that we have 5 to the first term times 5 to the second term. You see now? Okay, good. No, it's definitely weird seeing it used by going backwards because we've never done that before. We've never taken a single base with an exponent and said, okay, now we're going to split it into 2. So let me show you another example with like maybe just numbers. So for example, I can have maybe 3 to the, I don't know, 8th power. And for whatever reason, if you wanted to separate that, we can have 3 times, we can have 3 maybe squared times 3 to the 6th. Because isn't 6 plus 2 still 8? Or I can just keep separating that out, and maybe I wanted to do like that. Oops. Because 2 plus 3 plus 3, is still 8. Let me fix the writing here. Okay, there we go. Does it help seeing with just numbers like that? Okay. All right, let's keep going. Yeah, this is it's definitely different seeing it and then separating using the property. So I totally understand if everyone's kind of has pause when you're looking at the work here. That's why I have this on the screen. Okay, simplify. Log base 6 of 12 plus log base 6 of 3. So let me give you 1 minute to get a head start, and then we'll talk about what you did. Ideas. What did you do to start this problem here? Multiply 3 times 12 times 3. And why we do that? Like, why are we allowed to do that? Yeah, it's a property. We learned this on Wednesday. Remember, we go from the expanded to the contracted. So addition becomes multiplication, right? As long as they have the same base. So we do 12 times 3. Yeah. I don't know why I'm writing. I purposely typed all these to save time. So yeah, we used what we learned on Wednesday. We got 36. All right, we done? Oh, we're not done, Enzo. So let me give you a hint. Let me give you a hint. Looking at this base, this log base 6. So we're going to use this, and we're going to try to manipulate this number to hopefully also make it a 6. That would be our goal, to further simplify this. So our goal is to try to use, knowing this is a 6, we want to make this also a 6. So Naomi says we're going to, 36 is 6 squared. Now what can we do? We're going to move the 2 in front because it's one of our properties. And what does log base 6 of 6 become? Yeah, it becomes 1. So what is our final answer then? Our final answer is 2. Yeah, log base 6 of 6, that becomes a 1. The 2 moves in front, carries down, and that's it. So the thing with Unit 4 and solving all of these, every problem is very different. Just because we went over these first, these problems here, doesn't mean it's going to be the same for like these two problems. Who would have thought all that becomes 2? I know, right? Yeah. Yeah, I wouldn't have known until we actually got there. All right. The next one. Let me give you a minute here. All right, anybody have a final answer for this one? Enzo says 1. Isaiah says 1. Anybody else? The answer is 1. Yep. All right, what do we do? What did all of you do for your first step here? Yeah, there's a few things we could have done. Um, move. What do you mean move the 1? I'll move the 1/3. Yeah, there's a few ways to do this problem. Um, so let me. Yeah, so natural log of e becomes 1. So it's one of our properties, right? So this right here, this becomes 1, and then this basically moves in front, right? So this right here moves in front to be 1/3, and then natural log of e just becomes 1. And then from there, it's pretty simple to see why we get 1. 3 times a third times 1 is 1, right? We also could have moved the 3. Did anyone do it that way? Moving the 3 back to the exponent? Yeah, there usually isn't just one way to do these problems. So like we could have moved that 3 back to the exponent, and now we have natural log of e to the 1/3 to the third power. Does everyone see that? And then when you have a power to a power, what do we do to these? A power to a power property. What's a power to a power property going to do for us? Yeah, we multiply them. 1/3 times 3 is 1. So we have natural log of e to the first power, or just natural log e, and then natural log of e becomes what? We should all know this. Whenever we see natural log e, we should immediately know it equals 1. It's a little bit different way of approaching it. Both ways would be correct. So going back to this way, we could move the exponent in front of the natural log. And the natural log of e becomes 1. And then we're going to have 3 times a third times 1 is still 1. It doesn't matter. All right, we all warmed up yet? All right, everyone tried this first one. I'm going to give you. Well, actually, you just give me a green check when you finish the first one. Yeah, the first one is kind of. I'm not gonna say tricky, but it's kind of tricky. Well, not really. There's a really easy way to do it. Then there's like a kind of weird, difficult, long way of doing it. I'm going to show you both ways. Hopefully, you all chose the easy way, and you're able to do it in like 2 or 3 steps. Isabella still working on it? Oh, you're back. All right. What did everyone get for the first one? 1, 1. Everyone got 1? All right. How did everyone do it? Natural log of e became 1. All right. So we have e raised to the 1 minus natural log e. So everyone saw this as just changing this into a 1. That would definitely be the easy way of doing it. And then 1 minus 1 is 0. And anything to the 0 power is what? Yeah, anything to the 0 power is 1. Well, other than 0, of course, but you know what I mean. All right. All right. Who did it? Who did it this way and who got it correct? Who did it that way and got it correct? All right. Isaiah, what are you doing? Quit tabbing out. All right. Did anybody look at this and thought, hey, I'm going to write this as e to the first times e to the negative natural log e? Anybody thought about that? And yeah, so I'm going to show it that way too, which is really not the best way of doing this problem. So if you thought about doing that, because we know the same base property, we can separate it. But here's the problem. Now we have a negative. Now, when you have a negative, you don't want to put it into the exponent. It creates problems. It creates problems, but it just makes the problem a lot harder. You're making things worse for yourself. So when you have a negative exponent, okay, ignoring the fact that's in front of a log or a natural log, what does the negative exponent tell us to do? Yeah, it creates fractions. In other words, it means take the inverse. So if it's in the top, we just move it to the bottom. It just means the inverse. So it becomes e to the first times 1 over e to the natural log e. Does everyone see that? Because of the negative, we moved it from the numerator to the denominator. And then we're going to multiply these together. And then, oh, by the way, natural log of e becomes what? It becomes 1. So we're going to have that. And then we also could have combined it into a single fraction in that same step. I did it in 2 steps. So we have e to the first over e to the first, and basically a number divided by itself is going to be, well, 1, right? Yep. And that's it. So this first way is definitely the way hopefully everyone did it, but if you did it this way, it's not a loss. It's just a lot more steps to get to the same answer. All right. Everyone try the second one. Give me a green check when you finish it. And hopefully you're not typing these in, because if you're just typing these in to get a possible answer, you're not learning anything. You need to understand and learn how to actually do the steps to get to that answer, not just type it in. All right, what does everyone get for their answer? We got 1 again. All right, what did everyone do to start this problem? Change it to e to the 1/3 power. That is one way we could have done it. Absolutely. Let's. I'm going to go ahead and since a few of you actually did that, I'll do it that way, and then I'll show you how I did it. All right, so we're changing the e to the 1/3 power. All right, now what? Yeah, so we can move. So we have choices. We can move the 1/3 in front of the natural log, or we could actually move the 3 to become an exponent of that e to the 1/3 power. Yeah, so it's like a lot of you move the 1/3 in front, and that's okay. There's many ways to approach this problem. So a lot of you said to move it in front of the natural log. And then, yeah, either way. So natural log of e we know is 1. And yeah, basically like that last problem, right? Yeah, that's how we get 1. And we do it a little different. Brady, how'd you do it? Remember, guys, you can take Mike if you ever want to talk. You move the 3. Okay, so you did it how I did it. Doesn't mean that it's the best way. It's just how I saw it. So this required us not to rewrite the radical as a power, but either way is fine. And then everyone can see that cubing a cube root. See, we're cubing a cube root. So what happens to the radical and the power? Yeah, it cancels out. How cool is that? And then, of course, natural log of e, we all know, is 1. Yeah. That way seems, it's about the same number of steps, really. It's not really any faster. It's just different. Right. Let's try these problems. Oh, that's super easy. If you really look at the second one, you can do it in your head. Super easy. But yeah, give me a green check when you finish. Well, the first one at least, and I'll give you time for the second one. All right, what'd all of you get for the first one? 36, 36, 36, another 36. All right, looks like 36 might be the right answer. Oh boy. Brady's relieved because everyone else got 36 too. Doesn't mean it's right. Sometimes all of you are wrong together. What did all of you do to start this problem? Yeah, the 2 moves to the exponent. So yes, we're going to move this 2 using that log property to become the exponent of that 6. So yes. And then that 3 raised to the log 3, that stuff cancels out because it's one of our inverse properties. So that cancels out. The 6 squared carries down. Hopefully on your notes you show your the work like I did here by crossing that off, and then we can see that this carries down. And by doing this, it kind of cues us to show us that everything after that, whatever this may be, will carry down. And then of course 6 squared is 36. All right, everyone work on the second one. Give me a green check when you finish that as well. All right, what did everyone get? 2s. Yeah. What did everyone do to make this problem easy on themselves? Yeah, it just becomes 4 minus 2. Yeah, that'd be the easy way to do it. And we know that because if you just really look at what's going on, log base 3 of 3 becomes 1. Log base 3 of 3 also becomes 1. So the problem actually became super simple. Oops, actually that, let me back up. Dun, dun, dun. The way I did it, I'm going to show you a really bad way to do this problem. Well, not bad way, just a really long way. But yes, these cancel out, becomes a 1. That cancel out, becomes a 1. And then 4 times 1 is 4 minus 2 times 1 is 2, and that's how you get 2. So that would be the easy way to do that problem. Let me show you 2 other ways we could have approached it if you didn't see that log base 3 of 3 became 1. We could have moved these to the exponents, the 4 and the 2, because we like making things difficult for ourselves. And then maybe from this step, maybe you saw, hey, these are the same, so now this cancels out, and then the 4 carries down. And just another way to look at it. Same thing for that log base 3 of 3 to the second power. That cancels out. Oops. That 4 carries down, that 2 carries down to get 2. Another way to look at it, also we could have made things even harder on ourselves, and maybe you saw that we have log base 3 of this stuff minus log base 3 of this stuff, and you're like, hey, subtraction becomes what? So if we were to contract this, what does subtraction become? Division. So we could have gone that route too. Again, I'm not really sure why we would have done that, because the problem is so much easier than this. And now we're down to this. Now we have 3 to the 4th power divided by 3 squared. And then we could have reduced that. Hopefully you remember your rules about same bases and fractions, how you subtract the exponents and it stays on the side where it's bigger. So 4 minus 2 is 2. And then from here, then maybe you saw, hey, let's now go ahead and bring this in front, or let's go ahead and just cancel this out and make that a 1. So, and then that 2 carries down or in front, however you want to look at it. Yeah, just another way to approach it. But hopefully everyone went right to this work and the problem would have been super easy. But a few other ways. All right, now let's get to the change of base, the actual part of the lesson that I wanted to really get into. Change of base formula. All right, so this formula says log base b of a is equal to log of a new base of a divided by log of that same new base of your b, which is the old base. Or we could rewrite it as natural log. So instead of using log base b of a, we could make log a base of e. So log base e of a over log base e of b. And remember, log base e is the same thing as writing natural log. So for example, down here, if we wanted to use the change of base formula to write it as a log, as the common log, so log base what? So if it's not there, what is that base always going to be? Yeah, it's a 10. It's called common log. So without writing the base, it's always a 10. So we're going to rewrite this log base 9 of 4 as log 4 divided by log 9. Everyone on your calculator, type this in. Type in log 4 divided by log 9. And tell me what you get. And make sure you round to, do I tell you what to round to on this page? No, I don't. Give me 3 decimal places. Everyone type it in. The hard part on here is typing it in. Yeah, like Enzo says, this is useful if your calculator doesn't actually allow you to type it in with a different base. You know, the TI Inspires or TI graphing ones, I know those do. The Casio FX 115 and FX 300 also allow you to do that. But we still have to learn it. All right, everyone type it in. Type it in, type it in. Give me the answer. What is it? 0.631? Yep. And again, remember, we can also change this instead of doing like a log base 10 or a log or whatever. We can make it natural log. So everyone type in natural log of 4 divided by natural log of 9. Tell me what you get. Is it the same answer? Well, weird, right? Well, that makes sense because it says we can do it either way. Yeah, it doesn't matter. So we can make it as log. Remember, natural log is just log base e. So this formula, whether you change it to a common log or you change it to a natural log, it doesn't matter. The math is going to be identical, which is a good thing. That was the whole point of showing that, is to show that you can use common log or natural log. All right, let's try number 1. All right, everyone, convert this into either common log or natural log. And then it says approximate to the nearest thousandth. So approximate to the nearest thousandth. Give me a green check when you finish the first one. Now, I'm not going to force you guys to use the change of base if your calculator allows you to change the base to do the math. However, on your test or on your quiz, it might have fill in the blank that will ask you to do a change of base. I mean, you obviously need to know how to do it to fill in the blanks. All right, what did everyone get for your answer? 0.613. 0.613. Yep, same thing. And I chose natural log. You can just do log. It doesn't matter. I prefer to use natural log. I don't, just because. So natural log of 3 divided by natural log of 6. All right, everyone do the next one and give me a green check when you finish it. Math is fun with a calculator. More like boring. Well, it can be fun. Yeah, it's a tool to use, but if you shouldn't rely on it to, you should still know how to do it. All right, what did everyone get for number 2? So we got 2.640. Brady, type it in again. Well, so rounding. Let's talk about rounding real quick. When you typed it in, give me give me like 5 decimal places. 2.6 63597. 63. Okay, thank you. Yeah. 6. All right, 63974. All right, so on your screen, you should have got that plus more decimal places running out to the end of your screen. So we're rounding to the nearest thousandth. The nearest thousandth is 3 places because it goes. I'm giving a little review on decimal places. It goes tenth, hundredths, thousandths, 10,000ths, 100,000ths, millionths, and so forth. So thousandths is 3 places. So when I taught grade school, well, I only taught grade school like when I was actually in my undergrad. But when I did teach it, I would have them draw a line of what places we want. We want 3 places. So that's our door. Then I would tell the students, these, I don't know, I think they're 5th grade or something. I don't know, 4th grade. I forget. I would say if this number is a 5 or higher knocking on this door, it makes this one go up by 1. Well, that is definitely a 5 or higher. So because it's a 5 or higher, all we're going to do is add 1 to that number right there. And then we just 9 plus 1 is 0. Carry the 1. 3 plus 1 is 4. And then we have the 6 and then the 2. Oops. Thank you, new row. And hopefully your math teacher in grade school shows you something like that so it makes sense on how to round. If not, maybe it's the first time you've actually been taught how to round properly. You're welcome. And then we also, when we round to 3 places, we don't need to put any trailing zeros. So even though it does say round nearest thousandth, because this 3rd place is a 0, we don't need to put it in the answer. Now, if you do, I wouldn't mark it wrong. I'm sure nobody would mark it wrong, but you don't need to put any trailing zeros. So that 2.64 is rounded to the nearest thousandth place. All right, everyone feels happy about rounding now? Or maybe you felt happy about rounding before too, but now you feel happier. Okay, good, good. All right, go ahead and finish number 3 and 4 and give me a green check when you finish those two. We're almost done. What's the answer to number 3? 3.807. 807. Yep. And the second one? 0.979. I agree. All right, then our last page is this one. I have 4 more, so quickly do these 4 and then give me a green check when you finish all 4. We'll stop right here. All right, everyone is done. Let's take a look at all of these answers. All right, did everyone get all of them correct? Actually, hold on, let me do this. We'll do the number of stars. So select the number of stars that you actually got correct on this page. All right, everyone got all 4 correct. Nice job. All right, guys. Well, that's all I have today. So, as always, thanks for coming. I hope you learned something. I will see all of you back on Monday. And we only have 2 more lessons left for Unit 4, Monday and Tuesday, I believe. And then we'll have the review and the test. And I think we'll have Thanksgiving break next week. Do we have school Wednesday? I can't remember. We don't have school Wednesday. Are we? Are you sure, Enzo? Let me double check. I feel like we have school on Wednesday. Let me go to, before I stop the recording, people are actually curious and don't want to look themselves. It'd be great if we didn't have school on Wednesday. Yeah, it'd be better if we didn't have school at all next week. It's that short. Let's see. So today is the 12th. No, we have school Wednesday. I have it on my calendar. Wait a minute. Is my calendar? Wait, is Thanksgiving next week or the week after? Hold on, it might not be next week. Thanksgiving might be on the 24th or the 25th. Someone look this up. When is Thanksgiving? Oh, it's not
Look at
next.
Wednesday the 24th.
Bummer. Okay. Well, I thought Thanksgiving was next week. It's apparently the week after. I thought it was the third Thursday of every November. Is it the fourth Thursday of every November? I don't remember. Um, or maybe it's the last Thursday of the month. So it says, yeah, we don't have school on Wednesday, the week of Thanksgiving. So the 24th, we don't have school. So the week after next, we only have 2 days. And it looks like on those 2 days, we'll be starting the final exam review. So we will be done with Unit 4 before Thanksgiving, which is amazing. I know all of you are so excited. I know we're so close. All right, everyone, have a great weekend. I will see all of you on Monday. Take care.